this video, we will discuss about prime subtraction operation. You are given a zero-index integer array nums of length n. You can perform the following operation as many times as you want. Pick an index I that you haven't picked before and pick a prime p strictly less than nums of I, then subtract p from nums of I. Return true if you can make nums a strictly increasing array using the above operation and false otherwise. So what they are saying is that in the input we are given an array which consists of positive integers only, right? Now what we need to do is that we need to check whether we can transform this array into a strictly increasing array. Strictly increasing array, right? Now how can we transform it? So what we can do is we need to pick a prime number, right? And we need to subtract it from that particular number. And this prime number should be strictly less than the number from which we are subtracting it, right? So for example, for this 4, what are the prime numbers which are smaller than 4? 2 and 3, right? So we can choose any of them and we can subtract them from 4. So for example, if I choose 2, then I can subtract 2 from this 4, then I will get 2. So I can change this 4 to 2. Right? This operation can be performed any number of times on all these elements, and you need to find out whether after these operations are you able to transform this array into a strictly increasing array or not. So a strictly increasing array is one where all the elements are present in increasing order and there are no equal elements, right? Because it is written strictly increasing. Right. So now how are we going to do this? So see, for this 4, we have 2 and 3 as our prime numbers. Right. Let us suppose that I choose 2. Then in that case, it will be 4 minus 2, that is 2. Then for this 9, we have 2, 3, 5, 7. Right. Now let us suppose I choose 2 again. So it will be 9 minus 2, that is 7. Right. Now for this 6, we have 2, 3 and 5. Right. Now let us suppose I choose 2. Then 6 minus 2 will be 4. But now if you closely look here, this 4 is less than 7. Our array is no more strictly increasing, right? So if I would have chosen 3, then it would be 6 minus 3, that is 3. Again, our array won't be strictly increasing. If I would have taken 5, in that case, 6 minus 5 would be 1. In that case, also our array would not be strictly increasing, right? So then that means I will have to go back and I will have to choose some different prime number for this 9 in order to make my array as strictly increasing, right? Now, this is going to be very hectic, right? Because I don't know what are the numbers I am going to get in the future. So how will I identify that what is the prime number that I should consider? Or once I have moved forward, I cannot go back and keep on checking again and again that what is the prime number that should be the most suitable, right? So we will have to think of something else here. So see, what if I always choose the largest prime number? So what I'm saying is, let's just remove all this. So I am saying for this 4, we have 2 prime numbers, which is 2 and 3. What I am saying is that I will always consider the largest prime number, which is less than this particular element. Why? Because when you will choose the largest prime number, then whatever is the number that you will get after doing the subtraction, that will be the smallest possible number, right? So basically, if for 4 I choose 3, I will get 1. So this 1 is the smallest number that this 4 can be transformed into by subtracting any prime number, right? So for all these numbers, we will choose the largest prime number so that the numbers that we get are the smallest number. There is a minimal change in every number as we go in this particular array, right? And in that case also, if there is some number due to which our array is not becoming strictly increasing, then we can say that, okay, this is not a possible scenario and we can return false in this case, right? So for this one, we are choosing the largest prime number here. That is why we got a 1. Now if we see for this 9, so for 9, we will have 2, 3, 5 and 7. 7 is the largest prime number. So 9 minus 7 will be equals to 2. Now, if you see for this 6, 5 is the largest prime number, right? But if you will do 6 minus 1, then it will be 1, which is not strictly increasing, right? But here what we can do is that, see, our range shouldn't be till 6. Our range should be till 6 minus 2, that is 4. Why? Because see, we want to check whether we can create a strictly increasing array or not. We should consider every valid scenario to return our answer as true, right? So since till now here, we have created our array as 1, 2, then for this 6, we should check for such a prime number through which on subtraction we get a number which is greater than this 2. right? So instead of checking in the range 2 to 6, we will check in the range 2 to 6 minus previous number. Now why this 2? Because we know 1 is never a prime number, so we always start checking from 2, and then we will check for the current number minus previous number, right? And another thing to notice here is that in the question it is given to us, we need to subtract such a prime number which is strictly less than the current number, right? So basically for this 4, we are not having a previous element. Let us suppose this 4 was 3, which is a prime number. So you cannot subtract 3 from 3, right? Because you need to choose strictly less than 3, right? So then that means whatever is the number, you have to do its minus 1. Current number minus 1. And then you need to subtract previous also from that. So this should be a range. So I am saying that the range for checking the prime numbers should be from 2 to the current number, that is nums of I, minus the previous number minus 1, right? Minus 1 for the strictly less than condition and minus previous for making sure that we are creating a strictly increasing array, right? So if we check again for this 4, what would be our range? It would be 2 to 4 minus, now previous is nothing, so we can consider it as 0, and minus 1. So it will be 2 to 3. So we have 2 comma 3. Largest is 3, 4 minus 3 is 1. Right? Then if we check for 9, so it will be 2 to 9 minus what is previous 1. So 1 minus 1. So it will be 2 to 7. Right? So 7 is the largest. So 9 minus 7 will be 2. Now if we check for this 6, then the range will be 2 to 6 minus what is the previous element, that is 2, 2 minus 1. So it will be 2 to 3. Again, what is the largest prime number, that is 3. So it will be 6 minus 3, that is 3. Right? And then if we check for 10, so it will be 2 to 10 minus previous is 3 minus 1. So it will be 2 to 6, and the largest prime number will be 5 in this case. So we will do 10 minus 5, which will be 5. Right? And you see, this is a strictly increasing array. So we can say that in this case, our answer is going to be true. Right? So what I am saying is that in every case, we are finding out the largest prime number that is less than the current number, right? And also our range will be 2 to nums of I minus previous minus 1, right? So this is how we are going to solve this. So let's quickly look at the algorithm. So first of all, we will create a variable previous, right? We will create a variable previous which will initially be 0, because for the first element for this 0th index, let me just quickly write down the indexes 0, 1, 2, 3. So for the 0th index, we are not having a previous element, so we will keep it as 0, and then we need to run a for loop. We will run a for loop where I will start from 0 and it will go till I less than n, where n are the number of elements in the vector, right? And we will do I plus plus. So what was our range? Our range was 2 to nums of I minus previous minus 1, right? So let's create this upper bound. So we will create a variable bound. In this, we will write nums of I minus previous. Now see, one thing if you notice, if I am here at this 9 and I am checking 9 minus 1, which will be 8, right? Now let us suppose that there comes a scenario where this particular 9 is not 9 but 1. In that case, what will happen? 1 minus 1 will give you 0, right? But can we consider that 0? See, for 0, we can never find any largest prime number less than 0, right? So then that means if this particular thing comes out to be 0, then we cannot achieve our answer. We cannot create a strictly increasing array. Also, if in any case, let us suppose this was 1, then in this case, 1 minus 2 would give you minus 1, which is a negative number. And I said that in our array, we can have only positive numbers, right? So, if in any of the case, nums of I minus previous becomes less than or equals to 0, your answer is straight away going to be false, right? So, we will check that if bound is less than or equals to 0, then return false, right? If it is not, then we will check our range, which will now be 2 to bound minus 1, right? Because we have considered nums of I minus previous here. So now our upper bound will be bound minus 1. right? So now we need to find out the largest prime number, right? So since we want to find out largest prime number, we will start from bound -1 and we will go till 2, so that once we get a prime number, we can stop there itself because that will be the largest one, right? So we will run a for loop which will start from bound -1, right? And it will go till 2, right? And we'll do j minus minus, right? Now inside this you need to check that if j is a prime number. If j is a prime number, then that means this is the largest prime number that we are looking for, right? So let's create a variable here, p. So this p is going to denote us the largest prime number that we are considering. So we will update this p with j, right? And we will break out of our loop, right? So through this, we will be able to identify the largest prime number which is less than the current number, and it will be stored in P, right? Now what you need to check? You need to check that if nums of I, which is the current number, minus this largest prime number that we have got, if it is less than or equals to previous, then that means our array is not strictly increasing, right? So in this case, we will straight away return false. Otherwise, if it is greater than the previous, then in that case, we can consider this element, right? So we will update our previous to nums of I minus P, right? So this will be our for loop, right? And at the end, you can simply return true, right? So now, how do we implement this check prime? How do we check whether a particular number is prime or not, right? So you know that for a prime number, the number is divisible only by 1 and by itself, right? If it is being divisible by any other number which is not 1 or the number itself, then that means it is not a prime number, right? So how do we check that? For checking whether a number is a prime number or not, what we do is that, so this is our prime number function, right? So here we run a for loop which starts from 2, right? Because we know that 1 it will be always divisible. So we start from 2 and we'll go till the square root of x, right? You see, we can go till the square root of x, right? There is no need to go till x, because if there will be any divisible of x, it will already be covered in this particular range, right? So inside this, you can check that if any of the case x is being divisible with I, then that means this is not a prime number. So we will return a false, right? Otherwise, in the end, you can return true, right? So this is how we can solve this question. So now let's look upon the time complexity of this code. So if you see, here we are running a for loop n times, right? So if I write the time complexity here, so n times we are running one for loop. Now inside this, there is a for loop which is going from bound -1 till 2. What is bound? It is nums of I minus previous. For the first number, previous is 0. Now let us suppose that the first element of our array is the maximum element of our array, right? So in that case, bound will be equals to the maximum element. So we are going from maximum element -1 till 2. So just can I say that this loop will be running whatever is the maximum element, that number of times it is running. If I am denoting the maximum number of element in my array with m, can I say this loop will run m times, right? Although it is going till 2 and it is starting from -1, but these are very less difference, right? So we can say that this loop is running m times, right? So this will be n cross m, right? Now inside this, for checking prime, here we are running a loop from 2 till under root of x. This x was j and j was this bound -1 till 2, which we are denoting with m in the worst case, right? So in the worst case, this loop will run from 2 to under root of m, right? So we can say till square root of m, right? So this will be the time complexity of this particular code. Now, although this particular code will be accepted, but can we optimize it further? So see, what if we remove this part and we pre-compute the primes? In that case, we will be able to identify the largest prime number less than the current number in constant time, right? Now, how are we going to do that? So see, if your numbers are 2, 3, 4, 5, 6, 7, 8, and let's take 0 and 1 also. Now, I am saying let us create an array for all these numbers where At each index, it stores the largest prime number which is less than or equals to that particular number. So basically, for this 2, which is the largest prime number that is less than or equals to 2. So that is 2 itself, right? So I will store 2 here. Then for this 3, which is the largest prime number which is less than or equals to 3. So that is 3 itself. For this 4, which is the largest prime number that is less than or equals to 4, that is 3, right? And if you will see, 3 is nothing but the previous element in this particular array, right? So we will write 3 here. Now for this 5 itself is the largest prime number. For this 6, which is the largest prime number less than equals to 6, that is 5, which is nothing but the previous element, right? So this will be 5. Now, so what we are concluding is that if that particular number is a prime, where this 7 is a prime, so 7 will be the answer. And if the number is not a prime, then whatever is the largest prime number for the previous element, that will be the largest prime number for this particular element also. So for this 8, 7 will be the largest prime number. Through this, we can generate this array, right? And for this particular one, we are not having any largest prime number which is less than or equals to 1. That is why it will be 0. And similarly, for 0 also, it will be 0. So can we create this array? If we create this array, then for every number, we know what is the largest prime number which is less than or equals to that number, right? So then what we can do is that instead of running this for loop, we can check that what is the value present in this particular array at bound -1, right? And that will become our P in that particular case, right? So what we'll do is we will create an array, let's suppose primes. Now what will be the size of this primes? Till when are you going to store your prime numbers? So can we consider the largest element in our array? Because our numbers are always going to be smaller than that, right? So this primes array can be of size maximum element plus 1, right? And initially we can keep all the values as 0, and then we can start our loop from I equals to 2, because for 0 and 1 anyways the value will be 0 only, right? So we will run a for loop from I equals to 2. It will go till I less than equals to the maximum element, and we will do I plus plus, right? And now inside this, what we'll do is we will check that if the current number is a prime number, right? Then in that case, primes of I will be this particular number itself. Otherwise, primes of I will be equals to the previous element, which is primes of I minus 1, right? So now, instead of doing all this, what we can do is, here we will say that Rp will be equals to primes of bound -1, right? And then we can have these two conditions that okay, if nums of I minus p is less than equals to previous, then return false, otherwise update the previous, and so on, right? So now we have reduced our number of operations. So this particular thing, this calculation we are doing beforehand. This is the pre-calculation that we are doing. So here again we are running a for loop for the maximum element. So this will be m times. Inside this we are checking whether this particular number is a prime or not. So this would be running from 2 to square root of m. So the time complexity of this portion is m cross square root of n, right? And then here this particular loop is running only n times, right? All the operations inside this are of constant time. So now the overall time complexity of our code has become n plus m cross square root of m, right? So we have reduced our complexity, right? So I hope you got the solution. Let's code it out now. So first of all, we will find out the maximum element of our vector. So we will use a C++ function which is max element. So this gives us the maximum element of our nums vector, right? Then we will create a vector primes, right? What will be its size? Maxi plus 1. Initially all the values will be 0. Then we'll run a for loop of I starting from 2. It will go till less than equals to maxi, and then we'll do I plus plus. Now inside this we will check that if I is a prime, right? Then primes of I will be equals to I itself. Otherwise, primes of I will be equals to primes of I minus 1, right? Then we will create a previous variable which will initially be 0. We'll run a for loop of I starting from 0. It will go till nums.size. We'll do I plus plus. Now we'll create the bound. So our bound will be equals to nums of I minus previous. Then we need to check that if the bound has become less than or equals to 0, return false here itself. Don't go further. Otherwise, find out the largest prime number which will be given to you from the primes array. So it will be bound minus 1, right? Then check if nums of I minus p is less than or equals to previous. Then your array is not strictly increasing. Return false, right? Otherwise, update your previous to nums of I minus p, right? At the end, return true, right? Let's implement this check prime function. So it will be a boolean. It will receive a variable x. We'll run a for loop of I starting from 2. Then it will go all the way till square root of x. And then we'll do y plus plus. Inside this, we'll check that if x modulo I in any case is coming as 0, then it is not a prime number. Return false. Otherwise, return, right? Let's run this now. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.